Alright, so we've looked at how to divide polynomials with polynomial long division, but as with most things in math, there's more than one way to do it. The next way, for lack of a better name, we call it the CPM method because the CPM curriculum introduced it to us. They use a generic rectangle to teach you how to multiply, so we're going to use that process in reverse. Remember that the product is always found inside of the box. Well, in this case, that would be the dividend. The divisor will go on the outside, and our quotient we're looking for is eventually going to appear up here. I gotta figure out how to split up this dividend inside of my box, and I start by only filling in the first term, the x cubed. I'm gonna work backward to figure out how to fill everything else into all of these blocks, and end up being on the inside of the generic rectangle x cubed plus 5x squared minus 7x plus 2. Well, I know that to get this, I have to take this block times this box. So x times what is x cubed? It's x squared. So now I take that times this to come up with the value for this block. So x squared times negative 2 is negative 2x squared. The next thing we know about generic rectangles is that the right diagonals are always like terms. So those two blocks have to combine to equal the 5x squared. Well, right now I have negative 2x squared, so I would need 7x squared. So that 7x squared take away 2x squared gives me the 5x squared. So then I think, okay, I need 7x squared. I know it has to be something times x, so it's got to be plus 7x. So that's 7x times the x gives you 7x squared. So then I do 7x times the negative 2 to get this block, which is negative 14x. So now I know, okay, so these two blocks have to combine to give me negative 7x. Right now I have negative 14x, which means I would need positive 7x. So that's 7x plus the negative 14x gives me the negative 7x. So then I think, alright, I need 7x. It's got to be something times x, so I need positive 7. Then I take that positive 7 times the negative 2 to get this block, so I get negative 14. And then I know that these two have to combine to give me the positive 2. Well, I have negative 14, so I'd need positive 16, so that 16 take away 14 gives me positive 2. This final block will remain empty. I think about x times what gives me 16, but I know that's impossible with the whole value, so I'm at my remainder. Plus 16 over the x minus 2. There's my solution, and if you check, it's the exact same solution we got when we did polynomial long division. Once again, we're going to skip example 2 and move on to example 3. So example 3, same idea. The first term of the dividend goes inside your first box. The divisor goes down the left-hand side, x squared minus 3x positive 5. We work backward and think x squared times what gets us 3x to the 4th? The answer is 3x squared. So now I take that 3x squared times the negative 3x and get negative 9x cubed. Then I take my 3x squared times the 5 and get 15x squared. So my first column's filled in. I know that these two blocks have to combine to give me the negative 5x cubed. Well, negative 9 plus positive 4 would give me negative 5. So I need a 4x cubed here, so that 4x cubed take away 9x cubed is the negative 5x cubed. So now I'm thinking, okay, what times x squared gets me 4x cubed? The answer is 4x. So I take 4x times negative 3x and get negative 12x. 4x times the 5 gives me 20x, and my second column is filled in. Now I focus on this right diagonal. Oops. Take a look. It's not just 2 terms on this diagonal, it's 3 terms. So right now I've got to remember my x squared first of all, but I've got 15x squared take away 12x squared, which is 3x squared. I don't have any x squareds in my dividend. My placeholder is 0x squared. So 15 take away 12 is 3. I need to think about what do I put here so that when I take that plus 3 I get 0. The answer is negative 3x squared. So that if I add all three of these, 15 plus negative 12 plus negative 3, you'll get 0. No x squareds. Okay, so then we're thinking, what times x squared gives us negative 3x squared? It's negative 3. So then negative 3 times negative 3x is positive 9x. Negative 3 times 5 is negative 15. My next diagonal also has 3 terms. Right now I have 20x plus 9x, which is 29x. I need 4x. Well, 29x take away 25x would leave me with 4x. So then I think, what times x squared is negative 25x? Well, it's not going to be a whole value, so I must be on my remainder, which means I also need to think about the constants. I need negative 6, I have negative 15, so I want positive 9. So that negative 15 plus 9 is negative 6. Okay, so our remainder is this final column, negative 25x plus 9, so I bring that up top, plus negative 25x plus 9 over x squared minus 3x plus 5. So there's the solution. And if you go back and check, it's the same one we received when we solved for this problem via polynomial long division. Pause the video, try the second example of CPM method, see if you can get it on your own. When you're ready, come back and replay the video to see how you